Okay, today we're going to be looking at graphing polar equations. The first one is r equals 4, which we now know is a circle of radius 4. We could convert it to rectangular form by squaring both sides, which gives us r squared equals 16. And we can sub in x squared plus y squared for r squared. And you can see it's a circle with a radius equal to 4. And this circle is centered at the origin. So we'll go over here and do a circle. 1, 2, 3, 4. And that's your graph on the polar graph. So if anytime you see r equals a number, it's a circle with that radius, and it's centered at the origin. All right, next up is r equals 3 sine theta. Now to graph this, we are going to put 3 sine theta on a rectangular graph first. And 3 sine theta, we know the period doesn't change. The only thing that changes is the amplitude. So the highest point is 3, the lowest point is -3. So I want you to take a minute and graph that. Okay, so once we have that, we're going to go through and actually plot our 5 main points on the polar graph. And when we do that, we're going to go counterclockwise as we connect them. So we're going to start at the point 0, 0, which is right here. Then our next point is pi halves comma 3 as a point on the polar graph that's 3 comma pi halves because it's r comma theta. And that is in the pi halves direction 3 out, which is right here. So that actually flip-flops r comma theta. And the way you connect it is you connect it with a curve going counterclockwise. So it looks like that. Then our next point is pi comma 0, which is 0 comma pi. So that means you're actually back at the pole, and you continue to go counterclockwise. And then your next one would be -3, 3 pi halves, which is actually equivalent to 3 comma pi halves. So we don't need to plot it again because the graph, once it hits pi, actually starts to repeat itself. Now, what is that graph? That is a circle. If you converted this equation to rectangular form, you would see that. So I'm going to go ahead and pause the video and put that work there by multiplying both sides by r. And you will see that it's a circle that has been shifted up, as you can see that. Okay, so there in the dark purple, I converted it just like we did yesterday in class, multiply both sides by r, completed the square, so you can see it's a circle centered at the point 0, comma 1.5 with a radius of 3 halves. Right here, this is your rule to recognize you have a circle. So if you have r equals 2a sine theta and r equals 2a cosine theta, those will give you circles with a radius of a. And then if it's sine, the center will be a comma pi fourths, like you see here, meaning it's shifted up, and that point is in polar form. And if it's cosine, the center will be a comma 0. Okay, for number 3, go ahead and do the graphing on the rectangular graph like we did a few chapters ago, and then come back to the video. So here's our graph of 3 plus 3 cosine theta on a rectangular graph. Now we're going to convert that. So the point 0, 6 over here is r comma theta, so it's going to be 6, 0. So 1, 2, 3, 4, 5, 6. So you always flip the points. Our next one is now going to be 3 comma pi halves. So we go to pi halves and go up 1, 2, 3. Now remember, when you connect these, you always go counterclockwise with a little curve to it. Then we have pi comma 0, which is 0 comma pi. counterclockwise with a curve. 3 pi halves, comma 3, so that means we're doing 3 comma 3 pi halves, which is here. Again, curve counterclockwise. And then we end at 6 comma 2 pi, which is the same thing of where we started. And notice how you have a heart shape? That's called a cardioid. And you're going to know it's a cardioid because it's r equals a 1 plus or minus cosine theta, or r equals a 1 plus or minus sine theta. All right, starting with this one, again, go ahead and graph that in a rectangular graph. All right, so there's our graph. Again, we're doing the same thing. Instead of x comma y, it's r comma theta. So our first one is going to be the point, instead of 0, 3, it's 3, 0. 1, 2, 3, so that's right here, r comma theta. Our next point is now going to be 1 comma pi halves, which is right here. You connect it with a curve counterclockwise. Our next one now, this is a little different because it'll be going in the negative direction on pi, -1. You have to make sure, since this here goes through the x-axis, this over here has to go through the pole. And that's an important piece that we can't miss. So we have to make sure when we connect it, it goes through the pole to get there. Same thing on the way back. From pi -1 to 3 pi +1, we have to make sure it goes back through the pole. So 3 pi +1 is down here. And that's what gives you that loop. And then we end here at 3 comma 2 pi. And this is called a limacone. You know it's a limacone because the equation looks like this. So it's very similar to the cardioid, except that the values in front, like the constant in front and the value in front of the trig function, those numbers are different. And that's what gives you the limacone over the cardioid. That gives you the loop. So go on to number 5 and go ahead and graph r equals 6 cosine 2 theta. All right, so now that we have the graph, we'll go ahead and start graphing. So our first point will be 6 comma 0. Then our next one is pi force comma 0. So that's 0 comma pi force, which is just the pole. We connect it by going counterclockwise with a curve. Then we have -6 comma pi halves. So pi halves is normally up, but we're going in down. 1, 2, 3, 4, 5, 6. And we connect it with a curve counterclockwise. Then pi force comma 0 puts us back at the pole. Then we have 6 comma pi, which puts us out here. Then we have pi force comma 0, which is 0 comma pi force, which brings us back to the pole. Then we have -6 comma 3 pi halves. So instead of going down, we're going up. Oops, that's a 3 pi halves. Counterclockwise again. Then we come into the pole, and then we end at 6 comma 2 pi. And what this is called is a rose. So we have r equals a cosine n theta. So that n is what determines the number of petals. R equals a sine of n theta. So if the number in front of the theta is odd, then that's how many petals there are. If the number in front is even, like in this one, it's 2 theta, that means that there will be double that number of petals. So in this case, there was 4. So if you have 4 theta, we're going to double it to 8 theta. If you have 5 theta, it's just 5 petals. So you just have to pay attention to whether that's odd or even. All right, Next up is r squared equals 4 sine 2 theta. You're going to start by graphing 4 sine 2 theta. Don't worry about the r squared yet. All right, so this is what r squared looks like. So what we're going to do now is we're going to take the square root of it, and we get r equals the square root of 4 sine 2 theta. Now, what does that mean? We're going to go through and take the square root of all of our outputs. Square root of 0 is 0, square root of 4 is 2, square root of 0 is 0, so that gives us this little piece. Now we can't do square roots of negatives, so there's not going to be anything to find there. Square root of 0 is 0, square root of 4 is 2, square root of 0 is 0, and then we can't take the square root of a negative. So we're just going to be plotting those points. So you're starting at 0, 0, and then your next point is going to be 2 comma pi fourths, which is right here, and you're going to connect it counterclockwise with a curve. Then your next point is 0 comma pi halves, which puts you back at the pole. We skip over the next because those are negative when you can't take the square root. You're still at the pole with 0 comma pi. So our next one is going to be 5 pi fourths comma 2. So over here it's 2 comma 5 pi fourths. So 1, 2. And then we end up back at the pole. And so this is what that graph looks like. And this is called a lemniscate. So if you see an equation in the form of r squared equals a squared sine 2 theta, or r squared equals a squared cosine 2 theta, that's going to give you a lemniscate, which looks like the figure 8.